Hey, fellow programmers. Congrats on making it this far in this ATM project. This is our fifth and final video on this project, and we are going to implement our transactions portion of this program. So usually when you use an ATM machine, you are able to go and log into your online account and see a history of all the transactions that have been done on your account. And you may either choose to print those transactions or generate a report based on a time frame. It could be the last 30 days or last 3 months, 6 months, depending on the bank, depending on the financial institution's options. All right, so we are not going to go that in depth, but we are going to implement transactions, but we are going to implement a log of the transactions that have been performed on this account, and we are going to be able to save that to a file and also read the file's contents. All right, so let's go ahead and dive into the code. All right, so first things first, let's go to our transactions interface, and inside this we're going to declare a static Boolean function, and we're going to call this record transaction, and we're going to pass in a couple of variables. First, we need to save the transaction amount. And we would also like to know the transaction type, whether it was a withdrawal or a deposit. All right, so we're going to need a buffered writer. That's what I'm going to use to write to my file. So I'm going to create a new buffered writer object. And let's just call it writer and set it equal to a new buffered writer. And inside the constructor, I'm going to declare a new file writer, and we will need the name of the file. So let's just call it transactions.txt. And if you remember from our video where we declared files, we need to set the append flag to true. All right, so each time we perform a transaction, it will simply append to the file instead of overwriting that file. All right, so inside this try block, we want to use our writer to write. And let us include a Boolean statement. So let us say if the transaction type is equal to, let's say, credit, and we're going to use a ternary statement. So if it is equal to a credit, let us do a new line, and let's also tab, and we're going to say the amount that was credited. And let's format this with a $sign, and let us append the transaction amount. And I'm also going to concat a date to this so that we can know the date that the transaction took place. And to do this, we will need to use a date library. All right, so let us put another tab. And we're going to append local date time. And that imports our java.time.local date time library. And we're going to set it to now. So when we use the .now method, it will record that transaction at the time that the transaction occurred. All right, so now for the if portion of the ternary statement. So of course, with a ternary, we need a colon. And I am going to simply copy this. And if it is not a credit, of course, it has to be a debit. So let's say debited, and the transaction amount all right, so let's get rid of this additional parentheses. And here we have an error because we need to implement a catch clause. And I'm going to let IntelliJ generate this for me. And here we have our catch clause. I'm also going to print a custom error message. And I'm going to say there was an error. And let's just say writing to file. And of course, we have to return true, seeing that this is a Boolean method. Okay, so this method will indeed save the transaction amount, the type of transaction, and also the time that the transaction was done. We now have to add this method that records our transactions to our credit and debit methods. All right, so let's go to our account class. And first, let us do the withdraw. All right, so we can simply put it right here, and we can use the transactions interface's name and call the record transactions method. And we can pass in the debit amount and also pass in the string debit. So this debit amount will correspond with whatever is being withdrawn from the account, and the transaction type will correspond to whether or not this is credit or a debit transaction. All right, we're going to add pretty much add the same method to our deposit method. All right, so let us add it directly after our transaction. So we can say transactions that record transaction. And we're passing in the credit amount and also the transaction type, which is credit. So this will create our transactions.txt file and record the transactions to it. And it will save it in our current working directory. So it will save it inside our com.simple.atm namespace. All right, so currently we are not seeing a file in here called transactions.txt. Let us run our program and perform a couple of transactions so that we can. All right, I'll just expand this and run it. So let's see when the file is created. So let's stop and rerun our program. All right, so let's enter our pin 1423. Let's do a withdrawal of 500. Let us check our balance. All right, let us do a deposit of 4,000. Let's also do and let's do one more withdrawal. And let's do this one for 3,500. And then let us exit. All right, so now we see our transactions.txt file appear. And if we open up this file, now we're seeing the amount debited and the date, also the amount credited, and our second debit amount and the date that the transaction occurred. All right, so looking at the date time that was stored inside our transaction log, it is not looking very user friendly, and we can modify this to look a bit more user friendly. All right, so let me go ahead and delete these transactions from our file, and let us go ahead and make some adjustments to the transactions interface. All right, so what we can do, we can create a variable for local date time and set it to date time and set this equal to now. Next, we'll need a date time formatter, and this will import the format.datetime formatter. And now we can specify a format for our date. So we can say datetime formatter and .of pattern, and we can enter a string pattern that we would like our date to be displayed as. All right, so we can do a year, month, day format. And we can also do an hour, minute, second format. All right, so this is the format that we would like to be displayed. And finally, we need to store this value inside of a string. So let's declare a string called date time format and set it equal to date time dot format, and let us include the format variable. And so as not to confuse them, let me change this to date format. Okay, and I like to use camel case, so let me quickly change this to a camel case. And now, instead of using local datetime.now, I can use my variable datetime format, and let me enter that here. And now we should get a nicely formatted date. All right, so let's go back and run our program again. And let's do a couple of transactions. First, let's quickly withdraw 600. Then let us do a deposit of 1,400 or 14,000. And then let's do another withdrawal of 8,500. And then let us exit. And now if we open up our transactions file, now we see that we get a nicely formatted date, month, and day. And we also get our time in 24-hour format. So that's a lot better looking than what we had before. All right, so the final piece of the project is to simply read this transactions.txt file back into our program, just in case we need to read it back into our program and display it in our console. All right, so let us go about doing that. And let us define this function inside our abstract account base class so that each individual account that is derived from this account class can simply override the method if they need to. Okay, so let us enter it here at the end, and it's going to be a public boolean. Let's call it print transactions. So in order to print all the contents of the file, I am going to use a string builder so that I can build a string from each line of my document. And I'm going to call my variable contents and set it equal to a new string builder. And seeing that I used a buffered writer, I'm now going to use a buffered reader to read the file. So I'm going to declare an object called reader, and set it equal to a new buffered reader. And then in the constructor, declare a new file reader. And the file name that we're trying to read is transactions.txt. And I'm going to define a string that will point to the current line, which should be in fact be the first line of the document. And I'll need a while loop to loop through the file. So I'm going to say while the current line is equal to reader.read line. And while this is not equal to null, so while there are still lines left in the document to be read, we want to append the content to our string. So we're going to append the current line. And we're also going to chain another append method to this. And what we're going to append is a new line. So each record should be printed in its own line. All right, so now we have a few exception clauses to add. So let's add this catch clause. All right, so let's add our catch clauses. And at the end of this method, I want to do a system.out. And I want to print the content of the document. And let's also return true, seeing that this is a Boolean method. All right, so in order to test this method, we have some content already inside our transactions.txt file. So what I am going to do, I will simply comment out this portion of our program, and I am going to simply make a call to account1 dot print transactions, because we intend to print the contents of our transactions file to the console. So let us do a Shift F10. All right, and we see that we are now able to read the contents of our transactions.txt file to the console. All right, so with that, we have successfully implemented our simple ATM program, one that has an interface called transactions with some methods to withdraw, deposit, and get our balance. We also have a static method that records each transaction done in our system, and it records the transaction type, the amount, and also the date and the time that the transaction occurred. All right, so we have this date time formatting happening here. We have our abstract account class that is implementing our transactions interface. Okay, and our account class stores our account number, our PIN, and our balance. It also has a constructor that accepts a balance and allows us to set a PIN for the account. It also auto increments our account number. Okay. Down here, and you can go ahead and test this method. You can instantiate as many different accounts as you would like, and you can do a call to get the account number for each one of the account numbers, and you'll see that each of the account numbers will all have a different value. All right, we also have a validate PIN method that ensures that we enter the correct PIN. And we have our get next account number method that increments our account number. And of course, we are overriding the methods from our interface, right? So we have our withdraw method that checks to see if our balance is sufficient for our debit amount. It also records that transaction. We have our deposit that adds our deposit to our balance and also records the transaction. We have a method that simply returns our current balance. And then we have a print transactions method that simply prints the transactions that have been done in that particular account. And we're using a string builder to append the contents of the file. We're using a buffered reader to read each line in the file and a while loop to loop through the document. All right, so once that is completed, we're printing out the contents of the document and returning true. In our savings account, we are extending our base account class. We're adding an interest rate and we're setting the interest rate inside our constructor. We are also calculating the interest on the balance in the account. Okay. Inside our checking account, we have a fee, and this fee is assessed each time a withdrawal is made from our checking account. And we're also inheriting from the base account class and adding the fee to the constructor. All right, so remember this super keyword here. Super corresponds to our parent class, which is account, and we're inheriting the constructor implementation from our account class. And this is a simple method down here called getFee that returns the fee from our checking account. And of course, we have our ATM class that has all the different screens that we use on our ATM, just trying to simulate a real world example of an ATM that prompts us to enter our PIN, gives us a user menu to enter a numerical option, and then it has a menu or a screen for each that corresponds to each one of these menu options. And finally, we have our main class that allows us to accept a PIN from a user, and then once the PIN is validated, it displays the ATM user menu, and we're using a switch statement that corresponds with each menu option in our user menu. And depending on the option that the user selects, then that corresponding menu will be displayed and the corresponding action, withdraw, deposit, or get balance method will be executed based on that user option. And if they enter 4, of course, the program will exit. So with that, we have implemented a real-world simulation of an ATM machine.